framework.
Hot chocolate.
Azure Cosmos.
Dapper.
Entity framework. Power tools.
Technology suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shay Rojansky.
Chris Ransom.
Martha Vickers.
.NET data. T-minus 1 minute. Thirty seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
Welcome. We're back again with another .NET Data Community Stand-Up. To be honest with you, this is one we threw together because yesterday we realized we didn't have anything planned. So Shay's like, right, performance, update pipeline is what we call the implementation of save changes, by the way. I always wonder when we put update pipeline whether everyone knows what we're talking about at all. So save changes performance, which Shay has been working on a lot in EF7 timeframes. We're going to talk about that, answer any other questions you have around performance other than how do you make it go faster, which is general that you can never answer, but we'll do our best. Yeah, so I'm here with Jeremy and Shay as usual. I see from the chat we have people from all over the world joining us, which is pretty cool. So before we hand over to Shay, I'm just going to do a quick state of the unicorn. There's not much on it this week. We're continuing to push forward with development on EF7. So in case you've missed it, releases that are out now. I didn't update that. It's not 12 small enhancements. There's some other stuff in preview 3, which is on NuGet now, including we have an attribute mapping for composite primary keys. Finally, this is something people have asked for a long time. It's not the key attribute from data annotations because, for reasons I won't get into right now, changing any of the semantics or behaviors in data annotations is a can of worms. So there's another attribute called primary key. You can use it for non-composite primary keys, i.e. one property, but you can also use it if you want to configure a full composite primary key. And it looks very much like the index attribute we have, but for keys. So we've got that. We now support UTF-8 strings with SQL Server without doing any weird hacks like you used to have to do. Maybe the whole thing is a weird hack, but other than that, you don't have to do any weird hacks in EF anymore. And as we mentioned, there's a bunch of stuff, save changes, performance enhancements, which you may or may not see depending on the scenario, but Shay's going to talk about those today. Also, we have the latest patch of 604, only 4 bug fixes this time. This indicates that we're really kind of stabilizing down on EF Core 6. Yeah, we'll keep doing patches, but probably most of the stuff we've kind of got in there. There's still things trickling, and certainly report them, but it's stabilizing nicely. And then in the daily builds, I just merged value generation for simple types. So this is basically where, like a DDD pattern, where you have, for example, a product key class, or struct more appropriately, and it wraps an integer, but you still want the integer to be value generated. So that is now supported. So you can use the identity column backing it, for example. And then Andrea's continued to work on TPC mapping support for inheritance, and that support has now been added to save changes. So we've got Shay working on the update pipeline from one direction, and Andrea working it from the other direction. And I'm really hoping that they meet in the middle. They don't go like this, like when you're digging from two directions. But
just like the two unicorns,
right?
Exactly.
Yeah.
Yes.
It's gonna be fine.
It's manager concerns, isn't it? Anyway, so that's state of the unicorn. Without further ado, let's turn it over to Shay.
All right. So yeah, welcome everybody. So as Arthur said, this community stand-up is hastily thrown together in today in the last few hours, but I think it's going to be cool. This is definitely a deep dive. So this is about what happens inside EF Core. It doesn't necessarily touch on you guys as application developers using EF Core, but it always is helpful to know what's going on under the hood and to understand how EF Core does its thing. So perf is complicated always. In this talk, the kind of perf I'm going to talk about is a bit different from, for example, what I did in 6.0. So 6.0, I think maybe those of you who have been following, there was a big push for query performance. However, that was a push in terms of runtime performance. So when I say runtime performance, it's the kind of classical perf thing where you basically try to optimize EF Core's code itself. So EF Core has a certain overhead when you use it. There's C# code running there, obviously, when you use it. And the idea was to reduce allocations there, recycle certain things, make certain things go better, cut down some work. So it was basically reducing the amount of time spent inside EF Core itself. Whereas what I'm going to talk about now, so the focus of my work on the save changes on the update pipeline, is not at all that kind of thing. It's more about making sure that EF Core produces better SQL and executes it in a better way on the database. So it's a very, very different kind of perf push, if you will. In general, what we see is that any sort of optimization on that side, on the SQL side, and on reducing round trips is far more valuable than what we see when we optimize EF Core itself, because EF Core itself, as C# code generally is not so bad. It's already quite fast, and compared to what's actually going on in the database and all the time spent for packets going back and forth to the database, the actual overhead of EF Core there is not that big. And in the query performance push in the last release, we could see very nice improvements in the Tech and Power benchmark where everything is super optimized. It would also help for non-Tech and Power scenarios, but still it's a pretty, let's say, high perf kind of thing. Whereas what I'm talking about today, I think, is much less of an extreme kind of thing. I actually do think it's going to help a lot of normal users just doing regular websites with CRUD operations. That's actually why I'm happy about these optimizations. I feel they're very useful for everybody, for the common Joe using EF Core. So without further ado, every demo, every presentation is measured by time to code. That's like the main metric. So we'll just dive directly, TTC, time to code, to the code. So I'm using two monitors now for the first time. I'm going to move you guys over to this other thing. And if Jeremy can maybe put my screen on now.
Abracadabra.
Yay. So sometimes I'm going to look like this. This is when I'm like looking at you guys, and now I'm looking at the code. So I'm going to talk to my code now. Okay, so the first thing I'm gonna show you guys is, so we have what we want to do is we obviously want to, everybody's seeing this, yeah. So what we want to do is to compare EF6 performance with EF7. Now, what I've done here is I have a solution. I have an EF6 and an EF. Yeah,
what
go
you
ahead.
mean there is EF Core 6.0 with EF Core 7.0.
Of course,
right.
of course.
I knew we said we were going to call EF Core 7 EF7, but if we're now calling EF Core 6 EF6, we're going to really confuse things.
It's all just EF6, EF, man. It's just EF. No.
So just
No, I'm
deactivate. Yeah.
I'm
No,
just
this is
kidding.
all core.
All of this is core. None of this is old EF. Yeah, that's a very good point. And this EF6 here should be EF Core 6 for sure. And this one should also be. But anyway, so what we have here is two projects. They're using the same programs, yes, so exactly the same code, and the only difference is what dependency we have. So in the EF6 project, we're just targeting the released EF EF Core 6.0.4, whereas in the EF7 in the EF7 project, what we have is Preview 3, which has just been released. So everything I'm going to show now is already released, and you can grab it from NuGet.org and actually see these optimizations in real life and measure them for your scenario and so on. So the scenario is super simple. Once again, this is all targeted for super simple kind of scenarios. What you see here, we have just a normal C# thing. I always like to start my my test code, my demo code like this. We have a context and we drop the database and create the database. This way I can run it repeatedly, and I'm sure that there's no state. It's going to run from scratch. I'm not leaving anything in the database behind and so on. Now, what we're doing couldn't get simpler. There's no query. All we're doing is we're creating a new blog. We're adding it to change tracking, and then we're doing save changes. So we're inserting a single database row here. Not much to say about the DB context. I'm connecting to a SQL Server here. This is going to use SQL Server, this whole demo, on localhost. So this is not local DB. It's full SQL Server, but it's running on the same machine. That's actually super important. By the way, let's remove the SQLite here. We don't really care about it. And we have logging set at information. Once again, this is going to be a little bit important. I'll just make this go away as well. Our model is, again, as minimal as can be. You can see we have one ID and one name. Obviously, as most of you guys know, the fact that I have this ID here and it's an int, by convention, this is going to be the key. And by convention, it's also going to be that database generated. So it's going to be an identity column in SQL Server, which again is very important. So let's first run this thing and examine the SQL that comes out. So I'm always saying this, always examine your SQL. Always, not just when you're concerned with perf, but in general, it's always a good idea to kind of keep your hand on the pulse of what SQL is getting executed. So the main thing that you see here, of course, we have the table. You can see that this is an identity column, nothing very interesting here. And then we have the actual insert here. So if we actually dive into what's happening here, we can see there's three statements behind this simple operation. The first one I'm not going to spend too much time on. This is a SQL Server specific optimization that turns off a certain thing, just makes things go faster. It doesn't really matter and hasn't changed from 6 to 7. Here we have the actual interesting part, right? What we're doing is we're inserting into blogs, very simple run-of-the-mill SQL. We're giving the name and we're providing a parameter. Now, because this is the ID is an identity column, we have to fetch it back from the database. This is where it starts to be interesting, right? So we need to get the ID back, 1, 2, whatever got generated in the database, so that we can populate it back into the entity instance that you guys have in .NET when you use EF Core. This is how EF Core works, and this is how change tracking works. This is how everything around EF Core works. In order to do that, what EF Core 6 does is the following thing. It issues another statement, and it selects the ID back from blogs. And let's say the important thing here is mainly this. We're basically using some SQL Server magic to get back the ID where it is equal to the last identity value generated here. So basically, the identity value generated during this insert is going to be replaced by SQL Server here, and therefore we're sure that we can get the ID here. Okay, I hope this so far is pretty easy to understand. If we run the same thing, the exact same thing in EF7, we're going to see, EF Core 7. Now I'm super stressed because of Arthur. We're going to see something quite different. So what we see here is again, this is not the same. First, there's this new blurb here, which I'm going to elegantly not address. I'm going to talk about it later. We have the same set no count, but instead of having an insert plus select pattern, we now have a single insert, and what it has is this output clause here. So SQL Server supports, you can do insert and tell it in the same insert to return back one of the columns, typically you'd use that for a column that's generated in the database. Obviously, if I'm providing the column like name, then there's no reason for me to get it back. Usually you would do this with an auto-generated, say, identity column, right? So this is a single thing that does both an insert and a select, so to speak. And it's also guaranteed to give us the ID for the row that's already inserted. Okay, so we don't have to do that trick which you just saw with the identity scope and which row I want to, get the ID for. It's just part of the insert. So it's all very easy and simple, right? So already what you see here is that we've collapsed. We had 2 statements and now we have only 1. And that's already a cool win. It's a good thing, right? It's always better to do something simpler. There's not all that scope identity stuff. So it's simpler, and simpler is in general faster in terms of performance. But to be honest, this is not significantly faster. I wouldn't have done this just because of this, let's say. Just this little thing is not necessarily that important. And to understand why, it's important to understand that EF Core does batching. Okay, so all of these commands that you see here, let's go back to the EF6 one, EF Core 6. All of these, statements that you saw before, you can see in your logs. It's important for you guys to understand this for your own applications. This is executed in a single command. So you see in the logs, executed db command, and you see all the SQL under that single command. That means that EF Core packed these 3 SQL statements into a single command and sent them. And what that means is that we used batching, and we did 1 single round trip for these 3 commands. Had we not done batching, for example, if we had done first a round trip for the insert and then a round trip for the select, we would have had 2 round trips, okay? And that would have been bad. But we do already 1 round trip for all of these 3 things. So the fact that we collapsed 2 statements into 1 is not earth-shaking, okay? So why am I talking to you about something that's uninteresting? Obviously, there's a reason. So what I'm going to do here is we're going to dig even deeper into this, and we're going to switch to debug logging, okay, which is, by the way, the default, and we're going to run it. We're going to dig a little bit deeper into the logs to see what's happening. Let's see what goes on here. Okay, so there's lots of stuff now. There's a lot of CRUD around, but the important thing I'm looking for is, okay, here's my, here's the statement, and if I go here, I can see that a transaction has been started before my thing, okay? Before the insert.
Right?
Yep. Sorry?
This is in EF Core 6, right? You showed
this is EF Core 6, exactly. This is all EF Core 6, exactly. That's the older one. And if we scroll afterwards, then we see, yeah, EF Core 6, by the way, is super old if you guys haven't heard it. So it's so like, I don't know, 2021. No, I'm just kidding. That's just a joke. I'm just making jokes here. As you can see, we have a committed transaction log message right afterwards, right? So the thing here is, and I hope this is something that everybody is aware of. When you do save changes, we wrap everything that we do in that save changes in a transaction. A unit of work, so the thing that you do when you're reading stuff and then you save, you commit all your databases to all your changes to the database, is atomic. What this means is if something happens during that save changes that raises some sort of error exception, we're going to roll back the whole state so that nothing happened from that save changes. Everybody who uses relational databases is familiar with this concept. It's important, and we do it completely implicitly. So all your save changes are atomic. They're wrapped in a transaction. They're safe. You can be sure they either completely succeed or they don't succeed. There's only one problem with the transaction. The fact is that when you do this begin transaction that you saw before, and when you do this commit transaction that you see after, each time that is a round trip to the database. So in fact, what EF Core does here is it does 3 round trips to your database. While it batches all those things together that you saw, so all this stuff here is batched in 1 round trip in a command. Before that thing, there's a begin transaction, which is a round trip. And after that, there's a commit, which is a round trip. I want to just, drive this point home. I'm going to just write some ADO.NET code. So I want to simulate for you guys what happens, what EF Core does, as if you were writing it yourself. So let's say we have a connection here. We're using, this is the low-level code that is, generally kind of simulates what happens under the hood. We're going to open that connection, open async. And then let's say we have our batch here, execute the commands. That's the batch with the 3 commands that we saw. Before that, we do something like this. And that is where the extra round trips come from. We begin a transaction and we commit that transaction. This is a round trip and this is a round trip. Okay. And once again, round trips are my personal crusade in life, is to reduce round trips. The thing with round trips, the important thing with round trips, why I love optimizations that remove round trips, is that round trips depend on the distance between your application and your database. And here I'm gonna stop for 1 second and say a few things. So we're kind of used, let's say 20 years back, we were all used to the world of on-premise, where you have your application server, you have your database server, they're on the same local network. Latency between the two is typically very, very low. Okay, so a round trip, if you go, you do an extra round trip, it's not catastrophical. It's not amazing. It was heavy even back then, but it's not catastrophical. In today's world, very frequently you're going to be using cloud databases like SQL Azure or hosted Postgres in Azure or anything of that sort. And the database tends to start getting farther away. So the latency, the ping times, and all that stuff start to become more significant. And as that happens, every round trip that you do starts to cost you more in terms of overall latency, right? I've seen, so there's this trend sometimes where you see a company that has, a system that's developed for on-prem. Everything is on-prem, and now there's the cloud, and the cloud is awesome, and it allows us to save so much money. So we'll just take our application or cloud application or whatever, we'll just shove it in the cloud, and everything is going to work well. Sometimes that works out, but if the application was developed with a very chatty kind of design, so it was developed for an on-prem low latency network, then that's not going to fly, because as you take something that's designed for low latency, you put it in a high latency place, which is the cloud tends to be more in that direction. You're adding a lot of overhead over those chats, that chattiness. So round trips is something that I seriously recommend everybody look at. In our perf docs for querying and for saving changes, there's a whole section dedicated to reducing round trips in your application code. So this is not about internal EF stuff. This is about how to write application code in a way that reduces round trips. Very, very, very important. I really, really recommend reading that. But that's not my thing today. I'm talking about internal. So I'm going to delete this and go on. Let's look at what happens with EF7 at this point. So I'm going to run this.
The important question is how much does it round trip?
People have been commenting on how often you say round trip. That's all. It's fine. Keep going. Don't worry about us.
Thank you. I'm not looking at the comments. Sorry, but people are going to make fun of me for sure. Don't worry. I'm gonna be made fun of.
We will if they don't.
I know you will. So if I look at the EF Core 7 log, it's something magical happened, or maybe it's a bug. It could be a bug, and we don't know. I mean, of course, it's not a bug. There is no more transaction committed, no transaction started. What's going on here? So one of the things I kind of noticed when I was looking into optimizing is that, hey, if we're doing a single SQL statement, there's no need for us to actually wrap a transaction, right? Because in relational databases, a single statement is always already guaranteed to be transactional. And that's a guarantee that's very important. Otherwise, if you didn't have that guarantee, you could do like update something or something. And if for some reason there's some sort of crash in the middle, it would leave your database in some sort of inconsistent state, right? So transactions are generally needed only when you're trying to bundle up multiple statements in a single atomic unit. But in this specific scenario, we have only one statement that we're using, right? So once again, we have this thing here, which is a single insert with the output. So what I'm trying to say, this is maybe a little bit tricky, but the value of collapsing the insert and the select into a single insert is not so much in the collapsing, it's in the fact that it allows us to kill that transaction, that explicit transaction, and it saves us 2 whole round trips. Am I impressing people yet?
Yay.
Yeah, cool.
Yay.
That's very nice. But never take my word for it. Never take anybody's word when it comes to perf, which is why we're going to benchmark all this now, okay? So I always love to do benchmarking live because it's cool and it shows the actual figures. So I have these 2 projects here, which work in exactly the same way. They both refer to the same benchmark.cs file. And now I'm going to get on my soapbox. If you're doing any sort of benchmarking and you're not using the benchmark.net library, you're probably doing it wrong. Benchmark.net is a micro benchmarking library for .NET, which in general you should almost always use. Benchmarking is really hard. I don't trust myself to do benchmarking to make these decisions myself. For example, how much warm-up do you do before you start actually measuring? How many iterations are you going to do? Which number did you choose? Are you going to do 1,000 iterations, 10,000? Why did you choose that number and not another? These are decisions that are above my cerebral grade. I don't know math enough to understand any of that. So I delegate that to benchmark.net. It sounds like a shameless plug, but I'm not making any money off it. I didn't even write it. Other smart people have written benchmark.net, but I always use it to do my benchmarking.
Simple thing of how do I even time it? What APIs do I use to time it has a consequence on these things. So
absolutely
not just ticks minus ticks. I thought that was.
Well, you can do, but then are you doing it right?
So like every time we get these issues, I look at most of these kinds of issues where somebody opens an issue and says, EF core is low. Look at this scenario, and they dump their benchmark in the issue on GitHub, and it's great. I mean, it's great that people actually try to measure, and it's better than just saying EF core is low and not giving us code. That's the worst. But I see this code with benchmark, and a lot of times they're homegrown, and people do a stopwatch here and a stopwatch there, and many times the outcome from these issues is the benchmark is actually flawed, and when you actually code the benchmark correctly, you don't get the same results anymore because perf is very tricky and benchmarking is very tricky. And benchmark.net, which you're going to see in a second, is a way to make that a lot simpler for you. Seriously. So how does this benchmark look? Super simple. Our main code, our main program here, just does benchmark runner. This is the benchmark.net entry point, if you will. And I tell it to run the benchmarks in the benchmark class. And here I have the benchmark class. This is a class that's going to have just a single benchmark, which we're going to run once on EF Core 6 and once on EF Core 7. You see some connection strings. There's a local and a remote one. We'll go over that in a second. And then you have this feature here. I'm going to take 2 seconds to talk about it, which is dbContextPooling. So for those not aware, when you use EF Core, obviously you have a dbContext. You can instantiate a dbContext every single time, and that's completely fine. And in most situations, it's going to be okay. But if you're very perf-minded in general, what you want to do is you want to pool those dbContexts, because creating a dbContext every time has a certain overhead. That overhead is not completely negligible. If you are perf-minded, I would definitely suggest doing dbContextPooling by default if you can. There are certain scenarios, certain architectural constraints in your application which don't allow you to use dbContextPooling. I think those are rather rare. The average user, in my opinion, we've discussed this a lot with Arthur and so on, the average user generally can turn on dbContextPooling. There's no drawback to it, and it makes your application faster. So I would generally recommend that people look into doing this. It's well documented in our docs, so you should take a look at it. In these benchmarks, since we're concerned with isolating perf, I'm definitely using it. So what I have here, anything to say about this, Arthur? Maybe about anything controversial?
All right. You convinced me in our last meeting about this that we should push pooling more and only tell people, okay, don't use pooling if you need these features. I think it is important for people to recognize some things like integration with dependency injection is less functional when you use pooling, because you're not having DI create instances, and so likewise continuous configuration of different contexts with different configurations. But you've convinced me that the majority of people don't do those things anyway, so the majority of people should probably use pooling. And then if you do want to use those things, it's easy to switch to not using it.
That's pretty much what I think, and you said it even more succinctly. And there's other situations, by the way, where you can use dbContextPooling, but it's a bit more complex. If you're using if you're in a multi-tenant tenancy situation, you have to manage the dbContextPooling and the tenant ID that's going to switch around. That takes work. You don't necessarily care enough about perf to do that work, so it's fine if you don't want to use it. But I would suggest, if you're a little bit perf-minded, to do it by default. Sorry.
So
okay.
Julie's asking whether it's in the docs yet. It's not, but I think we decided to put it there, right?
There's docs on how to do multi-tenancy with dbContextPooling, by the way. So there is already some docs that helps with it. I think what we decided recently is to orient people a little bit more aggressively in the docs towards it by default, let's say.
Yeah. And I'm just
But-
going to say that after Shay finishes doing these benchmarks, then we'll come back and look at some of the questions that people have asked. So we haven't forgotten. We'll bring them back.
Right. I have a stop point soon where we're going to be able to discuss all this stuff. Very quickly. So what we have here, this is a benchmark.net attribute. I just want people to know how this works. So there's a method decorated with this attribute, one-time setup at the very beginning. So we build, the DB context options, and we build the pooling factory. So now this is the thing. This is the factory that's going to hand out these, pooled contexts all the time. And then we do the same thing that you saw in my main program. We create a context, we drop the database we created to ensure, a blank environment. And then the actual benchmark, it cannot get more trivial. It's called insert one row. We get a pooled context here. We add context, a blog, and we save it. I think it could not be. And again, this is very, very, minimal. So let's go and run this thing here. So I have a terminal here. I'm unfortunately on Windows, so I'm using PowerShell, which I do not like so much, but I think it's going to be simple enough that I'm actually going to manage. So I'm running this on the command line. Notice, of course, I said release because benchmarks you always run with release. Benchmark.net will refuse to run otherwise. That's another one of the ways where it kind of protects you. And what you see now is this is the warm-up phase. This is what BDN kind of looks like. Numbers are slightly different because I'm using StreamYard. This is running on the same machine, which is a big no-no, by the way. When you do serious benchmarking, you do not run on a machine doing, video, whatever, conferencing and all that. Yeah, I should shut you guys down and do the benchmark. I mean, it's more important. Anyway, can I ask Arthur and or Jeremy to actually remember this? Because I'm probably going to forget. So...
Yep. Here's how I remember it: 637, 637, 637.
Awesome. So Jeremy's going to keep doing that.
637.
Thank you, Jeremy. Jeremy's stuck in a while through loop.
It's really 638 because it's 637.9. So
thank you for that insight, Arthur. And we like to be quite pedantic in the team.
yes, we're software engineers.
Notepad is for transient thoughts. Okay. Just saying.
And now I will run the other one just to see what happens there. So keep in mind, this is running. Oh, of course, because I don't want to run it as a project like that. I want to run it on the command line. So,
release mode.
Exactly. And I also want to run it because if I run it like this from the UI, then I'm not going to see, it's not going to be nicely visible. So I want to run it in the terminal instead. So it's built, it's running. Keep in mind, this is now running against localhost.
963.
I think
it's in the chat now as well. So
I know.
Now it's never forgotten for all eternity.
This one will be slower because Jeremy was talking over it.
That's true. You're using up all my CPU, Jeremy. Be quiet.
It's in the band, not the box.
Well, even with Jeremy talking, I think we can see a certain improvement here, right?
Is this the localhost one?
This is the localhost one. Don't worry, I'm going to run the remote one in a second.
Okay, I'm itching for it.
I want to drive the point home. But you guys can already see we had, what was it again, Jeremy?
637.
Okay, and now we're at 441. So that's a 200 microsecond improvement for free without any sort of, work on your side, the user. But again, on localhost, but this is on localhost again, where round trips are supposed to be almost free, and they are, relatively speaking. So what I'm going to do now, this thing I'm now running on my laptop. It's a pretty crappy machine, by the way. It's not a good machine, and I have another desktop here on my network. So I'm going to switch to using this remote one. So let's go and run again the EF Core 6 version.
Did you change it? Oh, it's using the same file, so you don't have to remember to change it.
Isn't that useful?
Isn't
that useful?
Yes.
I know.
That wasn't even staged, actually. I genuinely thought, he changed it in both places.
Yes. So the numbers are quite different. Now I have a full disclosure to make. I don't have wired Ethernet at home. So what you're seeing here is over Wi-Fi, which is not a good thing. And it doesn't approximate anything that a real application is gonna. I sincerely hope your production websites don't run with Wi-Fi between your application server and your database server. But bear with me. This is just for fun. Our Jeremy loop is now gonna, I'm gonna input 8.2 into it, or rather 8.3 before Arthur does his pedantic thing.
So I'll just round it to 0.
Thank you, Jeremy. It's nice to have such cooperative supportive. And let's see what happens with the EF Core 7 one. Okay.
Ooh, it's looking faster already.
So that is
That's even the warm-up.
significantly
Wait,
faster.
wait. I'm trying to average these in my head. Hold on.
Good one.
Wait,
Now,
I'm almost there.
Are you doing a moving average? Are you keeping it up?
I wish I could say that my brain was.
Are you doing
capable of
standard
doing that.
deviation for me there?
I'm doing median. What was it? Medium absolute deviation.
You're way beyond my level now.
8 a.m. statistics classes that I never went to.
Right, I'm just a coder. Okay. By the way, notice that BDN does the number of iterations is going to vary based on the variance of the results. So if every iteration is very, very stable, then it's going to do less iterations because it already has the statistical, whatever. And if results tend to be like there's a lot of jitter, then it's going to do more of them. This is, again, an example why BenchmarkNet is so cool.
So I was thinking 4.34. Like, oh, look there.
Oh, nice, Jeremy. Nice. We should just use you instead of BDN.
So we went from 8.283 to 4.347. So that's just from round trips, basically.
Yes,
that's why
like
we say round trips all over and over again.
Exactly. That's double the time, and we're talking about a lot of milliseconds here. Milliseconds, for those of you doing web, are each millisecond is like very serious. I hope you guys treat it that way as well. So a millisecond is a long time to be spending just doing a silly round trip that you don't need to do, right? So I think, again, this should convince people. So this is cool, and it's nice that EF Core does this, but what I really want to drive home here is that you guys should be aware of round trips in your own applications, because that's the stuff you actually control. The way you actually code your round trips, both with EF Core and with other networking things. Always keep round trips like at top of mind when you're coding anything that does networking. Sorry. I think it's a good moment to pause and answer questions.
Okay, so we'll start with one that I think is quite close to your heart. Very cool. Will this affect Postgres as well?
Yes. Now, okay, because the question was there, I have to say something about this. It will affect Postgres in that it knocks off those 2 round trips. However, there is a little thing that you need to know. In NPG SQL, which is the Postgres driver, a long time ago, we made this optimization where when you do begin transaction in ADO.NET, that API that I showed before, it doesn't actually do anything. It just sets some sort of flag. It's a no-op that sets a flag. And the next time you actually execute a command, at that point, it's going to prepend the begin transaction to that. And that was an optimization. I think I did this in 2008. Like, this is super old, precisely in order to remove that round trip from the beginning of when you begin a transaction. I'm not aware of other. So SQL Client, for example, doesn't do this. So what you just saw was with SQL Client, and it does do a round trip for begin transaction and commit. However, for Postgres, this optimization is less powerful because begin transaction has already been optimized away at the ADO.NET level. However, it still works on the commit side of things on NPG SQL as well. My conviction generally is that any optimization you can do lower down the stack, you should be doing lower down the stack, like in ADO.NET, because this way, even people who don't do EF Core benefit from it. And there's a conversation with the SQL Client folk and with the MySQL connector maintainer, Bradley Granger, to maybe integrate that same kind of optimization. So that was the very long answer to your question.
I mean, I think it is worth saying that when looking at the update SQL that you need to generate to insert, update, delete, there are significant differences in the behaviors and what's available on different databases. So a lot of this stuff is complicated by making sure what we can do, even though we generate different SQL, but making sure the strategies that we take will work across different databases, right?
Absolutely.
But usually SQL Server is the hardest to make work. So
Yes, and we'll go into that in a second. That's my
Okay.
second big optimization here.
Okay, so question here. So when you were showing the transactions, does EF Core's older versions always run the transactions? And I believe this hasn't changed since EF Core was started, and I think EF6 does the same thing, right?
Yeah, that's right, with one small caveat. So yes, out of the box, if you anything you do when you do save changes, there's going to be a transaction there, and it's vital in order to ensure the atomicity. There is a there is a really not well known tweakable option in EF Core. I don't think it's even documented very well, where you can actually disable that behavior. So you can tell EF Core, don't do a transaction. I wouldn't ever use it. I think it was used mainly originally in order to disable that transaction for that case where there's one command
Yes.
in certain benchmarks. So what this optimization did, which I just showed you, is basically do that automatically for you. So if you are using EF6 today, EF Core 6, and you want to really like pedal to the metal performance, you can do this yourself manually by opting out of the transaction in save changes.
But be careful.
But be careful, exactly, because it's you should not be doing this when you have more than one command, and sometimes it's a little bit more than one statement, and sometimes it's a little bit trickier than you think to know when it's okay to do it and when it's not. I would definitely recommend against it, but it is there. So
I think we added it originally because the Tech Empower benchmarks didn't require that some things were done in transactions, so we just wanted to undo that overhead, but it's much better the way it is now. It's, much safer. So question here about Dapper. Now, I'm not sure that this is relevant because does Dapper do updates? I don't think it does, right?
Well, I mean, you write your own SQL with Dapper, right?
Yeah.
So you can run you can do a SQL that does insert this, and that, and then execute that, obviously. Dapper will not implicitly begin a transaction for you. That's for you to do. So I don't think a comparison here would be very valid. EF Core here is much more high level. It's doing a more high level service for you than Dapper is. Dapper is low level in that sense. You can use Dapper in the more efficient way, or you can use it in the less efficient way. You can always put a transaction there, and then Dapper will be conceptually as slow as EF Core in that sense. So
I do want to also point out, though, that as Shay mentioned, we did a bunch of query improvements in EF Core 6, and we are basically, I think, at 97% of Dapper for Tech Empower fortunes.
Right.
So essentially, if you're doing queries, link queries with EF Core 6 is on par with the performance of write your own SQL with Dapper. We love Dapper. Dapper has a lot of, it's a lot more lightweight. It gives you more control over what you're doing explicitly. But I think, and I think Nick and Mark would agree with this, that the number of places that you actually need to use Dapper for pure perf are pretty small now.
So there's still those cases where EF Core will generate SQL that is less efficient, and therefore you want to write your own SQL by hand and execute it via Dapper. So that does exist, and it's completely fine for some people to say, no, I want, again, pedal to the metal. I want to be close to my SQL. I want to write it myself and tune it. So you go ahead and use Dapper. That's completely fine and no problem at all. You can also use EF Core with raw SQL, by the way. So that's not always a great argument for using Dapper if all you want to do is write your own SQL. But yes, as Arthur said, a big part of the EF Core 6 push was to make them on par. They're not the same, but they're very, very close at this point.
So this one's basically asking, is a simple insert statement enough? And I think the point here was, for this benchmark, that's what you wanted to show to indicate, the round trips. Obviously, you've also been looking at a lot more than just a single insert statement.
That's right. And my next thing will show multiple insert statements, so a bulk insert scenario. But this kind of, I want to say that this kind of work that you just saw also affects update and delete performance. So the same thing when you do update, in various cases, when there's I'm not going to go into this because it would take too much time. But again, update will sometimes generate SQL that was more complex in EF Core 6, and in EF Core 7, you will see the same thing with an output clause that just gets values back. And that, again, allows us to reduce it to a single statement and therefore knock out the transaction that's wrapping it.
Okay. So somebody's asking whether the source is available, and I assume you mean for these benchmarks. I mean, really, it's trivial. If you want the source for EF Core, then obviously that is available on GitHub.
So yes, as you said, Arthur, I mean, I knocked this out in like 5 minutes. I'm not doing anything at all. But if you guys, if people want these benchmarks, yeah, holler on Twitter or whatever, and I'll put a gist over and link to it. No problem.
And now,
oh, good.
Sorry. No, go ahead, Jeremy.
No, I'll say. Do we have benchmarks in our test suites too? Is that correct? Yeah.
Yes.
We do.
For people who want to see examples of how
they need updating.
Yeah, the thing is, our benchmarks are there, and they're actually run continuously. So we use them to detect regressions. They're run twice a day automatically. The problem with benchmarks in general is that they have to match your scenario, right? You benchmark what you benchmark. For example, we usually check SQLite, but with SQLite, you don't really care about round trips that much because SQLite is an embedded database. There is no networking by definition, right? So if you run our SQLite, thank you, Arthur. That's awesome.
These are our Tech Empower ones. I'll just sneak preview of what we have here. So these are what we look at every week. We go down here. I don't know how much of this is public, so hopefully I'm not showing anything that.
It's all public. It's all public. Everybody can look at these.
EF Core benchmarks.
Right. So I would not follow this as an indication of at least my current work on perf, because these public benchmarks are running on SQLite, and once again, round trips are irrelevant there largely. And in general, we need to revamp these. We need to work on these at some point. That's just
okay. So a couple of personal questions for Shay. What RAM and CPU do you have in your slow laptop?
Golly, I don't know. I have 32 gigs, which is not that bad. I would buy 64 nowadays because sometimes I need a VM and so on. The computer, this machine is 3 years old now. That's what I'm going to say. So it does have 4 cores. It is, I think it's an i7. I don't remember the model anymore. It's not. It was super top notch at the time, but it's just aged.
Okay, and then a question that you're not going to answer, but I can't resist showing it.
The books.
Why are you not using Visual Studio? Oh well, let's not go there. But Ride is awesome. Okay, that's enough of that. Okay, I think we can move on.
Cool. So that was like one of that was my first let's say thing that I wanted to show. Let me now switch to another optimization, which is in a way going to be even more impressive, I hope. So the next thing I want to show is what happens when we insert more than one row. So what I'm going to do here, this is the same benchmark. I'm going to wrap this in a in a for loop, and I'm going to insert 4 rows instead of just 1 for instances, for entity instances. Sorry, what I wanted to do is this, and we'll even add it to the name. So okay, the scenario is again super simple. What you see is we're adding 4 blogs to the change tracker and then saving them. For those who are not familiar with EF Core, if this add thing doesn't actually do anything, it doesn't contact the database. That's the whole point. It's a good thing. What it does is it starts tracking this new blog thing, and it kind of has a list somewhere in memory and says, okay, we need to insert this when save changes is called. And when save changes is actually called, then it's going to do all of that in one round trip. Again, we're always about the reduction of round trips, the batching. It's always very, very important. What I'm going to do, I'm going to actually first run the EF7 SQL. That's actually going to be easier to explain because the EF6 one is super complicated. The EF7 one is also a bit complicated, but so you would expect us to simply do 4 inserts, I think, right? That's the easy kind of thing to do, right? You know what? I'm going to remove the debug here. I'm going to switch back to information because we don't need all that crud. I'm going to run this again. So once again, the trivial thing would be to run 4 inserts. And for any other provider, by the way, that would be the default behavior. But if I look at this thing, we see some monstrosity, I will say. We see something completely different in our SQL now. And that is because the EF Core SQL Server Provider uses a sort of a bulk insert optimization. It uses a SQL Server command called Merge. Now, Merge is somewhat infamous. It's a SQL Server command that's also available in Oracle. And by the way, coming to Postgres 15, the next major version of Postgres is going to have Merge as well, which is an interesting development, by the way. What Merge does, basically, I'm not going to go into it, but you have two tables, and you merge one table into the other. And you give rules as to what happens if there's already this row or that row. What do you want me to do? You want me to update it, remove it, whatever. That's the basic tenet behind Merge. And we use Merge for bulk insert. It's a bit weird, but what we say is merge into the table blocks. And here we give it, like, let's call this a virtual table made up with parameters that we send from the client. So we have one table, a virtual one, which we're sending, and there's the table into which we're inserting. And then we're telling it basically insert. The thing to do is to insert. So here you see the same kind of insert thing that's going to happen for each one of these 4 rows that we're sending. Okay. What we've basically done is replaced 4 distinct statements of insert with one merge statement. And I can tell you that even if you go before EF Core 7, even if you go to EF Core 6 or even 3.1, as you're adding more and more rows, if you're doing a lot of inserts, then that's going to be massively slower than doing a single big merge in this way. This technique is very, very much faster. Okay, and this, by the way, is an advantage of using EF Core. EF Core can be said to make your application faster in the sense that we give you this kind of optimization which you don't need to know about. I don't think there's a lot of people using this kind of technique out there when they're inserting multiple rows, because it's very you have to be an expert in SQL Server, and you have
esoteric.
to. Yeah, it's very esoteric, exactly, as Arthur said. So this is an added value of EF Core in a way. We do this work for you at our level, and you don't have to worry about it. You just said, add 4 things into the table, and we did it in a way that's very efficient. Okay, now, here, what you have here is the same output insert kind of thing, okay? Now I want to go and show you what EF Core 6 did, which is going to be a little bit painful to explain, but I hope I'm going to do a good job. So EF Core 6 does something that's a bit similar, but more elaborate. So we see the same merge with 4 things. But before this, what we see is this declare here. So I'm going to really do this quickly. What we're doing here is declaring a table variable. Let's call this a temporary variable. So we've created a new table in SQL Server, so to speak. It's called inserted 0. And here, the output, we're telling SQL Server to shove all these auto-generated IDs into that temporary table. So we created the table. We merged everything into blocks. And all the generated IDs, we put into a second table called inserted. Are you confused yet? You should be. This is confusing. And after all that stuff,
we're going to talk about why we did.
Yeah, we're going to talk about why. In 1 second, we're going to talk about why. There's a reason for all this. I've waited in order to give you guys the story. But after this thing, we have the IDs in the temporary table. We still need to get them back, remember, in order to populate them into the entity instances. So now we do a select from that inserted 0 thing. So you can see this really is like a table. It is a temporary table. In any practical sense. So this is hugely complicated. Before talking about why and why I could simplify this and what this whole thing means, I again want to do benchmarking on this, just to wow you guys once again, because benchmarks are the best. So I'm going to go into my benchmark here, and I'm going to do the same. I'm going to take this for loop here. I'm going to do the same thing here that I did before. Right? Exactly the same thing. And I'm going to go into my terminal.
Are we going to do this with remote or local, or does it not?
Let's do it with local. You're right. Good point. It's going to be more useful with local. It'll be more impressive with local too. But the thing is that there's an interaction here with the previous optimization with the transaction, and I don't want that to interfere. I want to isolate the second optimization. So if I do run now, so this is the old one, the more complex one with the temporary table one. Let's see what happens. Okay. Does anybody still remember how much it took to insert a single row with EF Core 6? How much was it? 630 something micro?
637.9.
Nice, Jeremy. Nice. Okay, so what we have now, it's 4 rows. So we have 2,184. Okay, because a millisecond is 1,000 micro. Okay, so 2,184 milliseconds. Let's go into the other one and do the same. Are you in suspense? Are you in suspense?
Wait, they're trying to throw us off by showing nanoseconds. Whoa.
Okay. So same code, same benchmark, inserting 4 rows. This takes a fourth of the time taken by EF Core 6. So we've basically, for inserting 4 rows, EF Core 7 will be 4 times as fast as EF Core 6. That's nice. That is pretty cool. And now for the backstory, because the backstory here is the important thing. So first of all, why is it so slow? The reason that it is, I'm going to show you the SQL again so we can discuss it. There's a good backstory. So it turns out that doing this, writing into a temporary table, all this adds an enormous amount of overhead, unfortunately. And that's most of what makes this slower. But also, this thing, this merge with select has to be wrapped again with a transaction, whereas the EF Core 7 version does not, because it's just a single merge. So again, we saved on the 2 round trips. So what you're seeing here is the intersection of 2 different optimizations. I love it when that happens, when you kind of see the intersection of 2 things and they're like doing synergy. It's amazing. And now for the backstory. So what's the deal, and why does EF Core 6 does this? So the problem is this: SQL Server is a little bit finicky. I'll use that word. And the problem with EF Core 6 is
that's not the word he uses when we're in private team meetings, by the way.
Yes, I'm much more explicit, anyway. Let's say. But I'm in public now, so I'm going to be well behaved. So SQL Server, when you use the output clause in general, the output clause is not allowed in certain scenarios. And the main scenario being tables which have triggers. Now, I know this is the most random, irrelevant thing, but it is what it is. If you have a trigger defined on a table, you cannot do insert with an output clause. This also applies to the original single row insert that we saw. Okay, this is why originally EF Core, instead of using the output clause, we were aware of it. Okay, when we wrote this, it's not that nobody knew about this clause, but we did insert and then select because we wanted it to work on tables with triggers. There's another minor scenario which I'm not going to go into. The one with triggers is the one that is the most important. And this brings me to a nice theoretical point, which I think it's an interesting, like, philosophical kind of thing. The frame of mind at the beginning was to say, okay, we want EF Core to work out of the box on all scenarios. So we don't want you to care about whether you have a trigger, you don't have a trigger. We want EF Core to just work. And that makes a lot of sense. And the decision was made to avoid using that clause because it doesn't work everywhere. It isn't universal. So we opted for something else, which is, we thought, slightly less performant, so that EF Core will just work out of the box to avoid forcing all kinds of friction on you in case you do have a trigger. What we're doing now with EF Core 7 is going slightly in the other direction, because this is a 4-fold increase in performance, okay, what you see here. By the way, yes, I skipped over a point. The astute among you have noticed that even the EF Core 6 one does use an output clause, although I'm telling you, you should not be able to use it with a trigger, with a table with a trigger. So it turns out that output is one thing, but output into is a different thing. Once again, very finicky. Output into another table is fine even if you have triggers, but output without into is not fine. Don't ask me. I'm not a SQL Server engineer. I have no idea. I'm just the guy writing the ORM. This is how it is. So we opted for this technique, which works everywhere, but which unfortunately is 4 times slower. Now, I don't think we benchmarked completely back in the day, all the different possibilities, and we didn't necessarily have the full visibility of everything. But today we know that this is 4 times as slow. And so what we're saying is this thing. We could keep EF Core slow by default, but working everywhere. And then we could add an opt-in for you to say, oh no, I want the fast mode. And then you opt into it. If you have triggers, well, you're opting into it, so there's no problem. You're opting into it, you're saying there's no triggers, and then EF Core is fast. That's one possibility. What I advocated for, what I think is a better approach, is to say EF Core should be fast out of the box by default. And for those people who do have triggers, yes, this will break. So this is a breaking change. And people with triggers doing inserts will start to get an exception. That exception is very, very informative. It points you. Sorry, is somebody saying something?
No.
I heard a noise. So if you do try EF Core 7 on a table with triggers, you will get an exception. So it is a breaking change, but it will guide you. It will tell you exactly what to do, how to tell us that you have a trigger so that we generate the less efficient SQL. So it's like two different worldviews. I believe that products should generally be fast out of the box. And if there's an esoteric case where they don't work, then, that's okay. And we should offer a knob to opt out of the, the fast mode. The opposing view would be to say, always be slow out of the box and allow people to opt into performance. But the problem is that you don't know that you're slow, right? If you're just using EF Core out of the box, that means that 90% of the people who I'm going to venture don't use triggers are going to be needlessly slower than they could be, because they haven't read our knobs and performance tuning guide, right? So what we're doing, at least for now, in EF Core 7, and of course we're open for feedback. This is very early still in the release, so we're very open and can change, decisions. What we're saying is that if you have triggers in your tables, you're going to break, but you can do something in order to tell us to do the other thing. And I will show that workaround just so that we do this, the whole thing. So I'm going to go back to not the benchmark, but the normal thing. What so you can tell.
Show how to tell us we've got triggers, but
exactly.
Can't we detect if there's a trigger?
That's a great question. And the answer is not really, unfortunately. So first of all, EF Core doesn't even always create your tables, right? Sometimes you use it to work with a database that already exists. We can't reliably start sniffing around your database to check if there's a trigger. By design, we don't do this kind of thing. We don't try to inspect your database with this kind of thing. We rather rely on you telling us these kinds of things. Yeah, I hope that makes sense. But
I mean, even if we could inspect to see if there's got a trigger to do something different, the fact of doing that would be slower than just not assuming there was a trigger in the first place. So not only is it not robust, it usually in the end game doesn't actually make things overall faster. So
if I'm devil's advocate, we could do this like the first time and then cache it, the knowledge and so on. But yeah,
I could get into all the issues we had in the old stack of trying to do things like that as well.
Yeah, I agree. I mean, I agree. I don't think EF Core, we prefer in general our users be explicit with us about these kinds of things. There's another reason, and I think it will become apparent once I show the code. So how do I tell EF Core that the blogs table has a trigger? Easy. I go into model building, like the normal thing, and I do toTable. This is where I configure the table to which blogs is mapped to, and I can say this table has trigger. And I give it a name, food trigger. Okay, so we have now declared that the table mapped to blog has a trigger. Okay, it seems weird because we've not actually said what that trigger is. There's no SQL here. Triggers have SQLs, but what we've only done is added that API to say that there is a trigger. Now, this is going to be in the future the API that you're going to use in order to actually configure a trigger. And EF Core could, generate that trigger in the migration. So this is the beginning also of a trigger management API in EF Core, but we're not going to complete it for EF Core 7. It just so happens that we're interested in knowing if there's a trigger for the perf thing, for the insert performance, and therefore we just introduced this stub of an API, if you will, for declaring triggers, basically. And if I do this, I'll just run this, and then I'll shut up.
Oh no, okay, it's working.
And if I do this, then you see now we're doing EF Core 7, and you see the temporary table. So you see the slow SQL here. Okay, so we've basically we have in EF Core 7 the same mode that you also have in EF Core 7 inside, but it's behind a switch. If the table has a trigger, then we revert to EF Core 6 behavior. If it doesn't have a trigger, which is our default assumption, then we do the optimized thing.
So I want to come back to the thing about doing the perf thing and then opting out of it, and I think in this case that's the right thing to do. I hate that merge temporary table thing. I mean, I've got another story about that I'll come to in a second, but I think there is another factor here that Shay touched on, but they are slightly separate things. Like when we were doing the initial version, you could say do the perf thing or not do the full coverage thing, and that's one choice. Once you've got to version 6 and you're now doing version 7, the breaking change thing is significant. And historically, I think people are aware, like in .NET Framework, that kind of breaking change would never have ever made it past any kind of like review or anything. But like, no, you cannot break existing functionality. We're kind of relying on more of an interaction between people writing the applications, like you guys basically, and the team and everybody to say, hey, we want to make this fast by default for the reasons Shay said, and because it's so much faster. That means some people are going to get this breaking change, and they may have to go and change their code and say, how's trigger? And I think that's the right way to go, but it's not an easy decision to make. We have a lot of applications out there and a lot of people, and we don't actually really have good data. We can't really tell how many people have triggers or not. So we know we're going to break some people. We don't know how many. So all the people in the chat and all the people listening here who are saying, this is the way to go, I agree with you, but recognize there's also going to be a bunch of people who are probably not watching this who are going to be pissed because they try and update to EF Core 7 and their application breaks. So that balancing thing, I mean, before I came to Microsoft and I was working on stuff that is used by so many different applications, so many different developers out there, you don't really understand how breaking changes can be so significant. But I think we're doing the right thing here, and I think the modern .NET is really kind of following along with this idea that yes, we don't want to break things, but also we don't want to stagnate. We don't want to just say we made a bad decision 10 years ago and we have to stick with it forever. But it's always a balancing act there.
Right.
And Shay is also always very much for the breaking changes, and I have to try and bring Shay and the rest of them, bring them back and say, do we really want to make that breaking change? Is the value really that much more? This is a case where the value is that much more. If it's a case where it was a few percentage faster, we wouldn't have made the breaking change for that, even though philosophically it's kind of the same. It could have been the same thing. So there's a bunch of questions, but before we get to that, I want to just add my story. Can you go back and show the code, the SQL that generates that temporary table, just in your output down there?
Of course.
Yeah.
This.
Yes. So notice there that you create a table and it's got ID int, position int, right? So we have to create a table with the same types that you have in your model. In reality, what we actually try to do is create a table with types that will at least accept the right amount, they won't truncate any data. They're not narrowing, basically. So we do our best to create types like that, like a string that will accept anything. It's not actually possible for decimals to create a decimal that will cover any other decimal, right? Because you've got the precision and scale, and depending on how you vary those two things, you either miss off one end or you miss off the other end. That is the whole reason why you get that warning if you have a decimal property and you haven't told us exactly what type it is. That's the reason that's there. Because if you just say decimal and we assume it's 18.2 or whatever, and even if we put the biggest decimal we can into the temporary table, we could end up messing up your data there. And that's really one of the primary reasons I've really always hated this thing, even though the idea was let's make it so that it covers the case with triggers kind of automatically. So for that reason, I'm I'm really happy we've changed that. It's also interesting that since always encrypted has been a thing, specifying the exact types for things is much more important. And SQL used to be, SQL Server and SQL Client used to be very lax about, well, it's a string, I don't really care what it is. It's a decimal, I don't really care what it is. Now it's like, okay, that's the wrong type, I'm not even gonna allow it. So this is kind of where things have been moving underneath us, and I think we're reacting to that in a sense as well. Yeah, so some questions, Shay. Let's do this one first because there's been quite a bit of discussion on it. Any news on executing insert, update, delete statements without preloading the objects?
Right. Okay. So on the update delete side of that, insert is a different beast. We for EF Core 7, one of our main features is what we call bulk update, which is exactly that. So we are intending to introduce an API where you can just express an update or delete directly with via a link query for the where clause. So that's a different update per feature. That's completely orthogonal to this. What I'm working on here is improving the change tracking version of story of updating and deleting and all that. Whereas there's another feature coming in EF Core 7, likely later in the release, that's going to take care of that. Insert is different. Insert is you're probably now talking about bulk import, like the SQL bulk copy kind of thing. We do have plans for this, but not for EF Core 7.
Right. See, so Catlin Pop says that even though it's esoteric, he's been using Merge for 15 years. Well,
Right.
That's cool. You're the exception, I think.
So I don't think Merge is esoteric, but I do think using Merge to speed up multiple inserts is esoteric. That would be my my guess.
Yes.
And by the way, I will just say there's another thing called upsert. That's another file I have, on the back burner. A lot of people use Merge on SQL Server to implement a sort of upsert. I've been looking into that recently. If you're doing that, be aware that Merge is not actually atomic, and you can have a lot of problems with it. So Merge is you should be very careful with Merge in general.
So on the triggers thing, there's been a few comments on triggers. I guess this one kind of is something that we've asked a lot on the team, which is using triggers really the exception nowadays? Or I guess, is it still the norm? Or more generally, how many people are using triggers? And we don't really know that. Certainly, if you are using triggers, it would be kind of good to understand why that is. I think that relates to this other comment that was made. Triggers are spectacularly good at hiding logic. If something's happening by magic in your DB, it's probably a trigger. Yeah, I don't know that that's a good thing. I think it's probably not a good thing, but maybe people think it is. And then another one here from someone who's saying, we have triggers, and I think the EF team have made the right decision. So that's
someone opting into
good.
our change.
Yes.
I love it.
Cool.
Yeah, I
Yes.
think on recent projects, a lot of times I see triggers used as a least trust type implementation, right? So it's, I don't know what application might touch this, so I'm going to enforce business logic in the database, as opposed to trusting that the application's the gatekeeper and understanding source of truth and interactions and other aspects. So that's the biggest shift I think I've seen in the past, I don't know, 5 to 10 years, is people having more trust in code managing the data than having the database manage the business logic around the data, is what I mean.
Exactly, I agree. We have a couple of comments here which are basically the same thing, which is using them for audit. Look into SQL Server temporal tables, history table, which will automatically create an audit without using explicit triggers. And again, this one basically the same thing, triggers for history tables. So I think that's something that there's better solutions than triggers for a lot of that now.
To add to that, it's interestingly similar to the discussion around SPROCs, right? Stored procedures.
Yes.
It's basically very similar, like how people used to define their logic in the database as SPROCs and call that. And same problems. Your code is not in source code, source control and all that kind of stuff. Anyway, that
Yes.
discussion is well known.
I don't have it marked, but there was a question about stored procedures. So just the usual answer, you can query from stored procedures already. We're adding support to map, updates, inserts, and deletes to stored procedures. That's coming in EF7 as well. So yeah, it's full use of stored procedures. I mean, most of what you want to do with stored procedures is already there, but if you do want to map them, your inserts, updates, and deletes, then we're going to support that too. Let's see. So this one isn't directly related to what we've just been talking about, but it's related to pagination and round trips, which I know is two things that Shay is quite interested in. So I was just putting it up there for you to read, and I don't know if you have a comment or not.
So my first comment is that in 2 weeks, we have a community stand-up dedicated to pagination.
Yes.
So I really recommend coming. If you got anybody doing pagination, I'd recommend tuning into that. And so I don't have the context here. Definitely anything you would do to reduce from 2 round trips to 1, you should do. If you can't, if the code is important and you can't get EF core to generate the right thing for you, then definitely, and again, and the perf, justifies it, drop down to raw SQL.
Yep, agreed. Okay, so one here that I'm going to put up because we are. It says, do you guys speak with the SQL Server team? Is there a chance they'll fix the trigger issue in the future versions? We've had a lot of, without washing our dirty linen in public or whatever, we've had a lot of trouble trying to get good communication with the SQL Server team, but it's been getting a lot better over the last year or so. And we've got some good context there now. We've had some good discussions over that. I don't know if some of these things are going to change anytime soon or not, but we've at least started we've at least got a good dialogue going there now. So yeah, working with them to try and make some of these kind of tricky, what was it that you called them, Shay?
Finicky
things a little better. Yes. Okay. Let's see. Sorry, Toast is barking here. Window functions in EF8, don't know, possible. And sorry, got a package delivered and Toast has to bark at everything.
He has to approve the delivery, man.
Yes.
I don't think he's being approved.
No. Okay. And then just a couple of I think we're pretty much out of time. Well, we're 15 minutes over, which is our normal thing, right? So somebody was asking, do you happen to dub Family Guy's Cleveland? You sound pretty similar. I wasn't aware that Cleveland was British, but I don't know. I can't really remember. So no, I don't dub Family Guy's Cleveland, although I think that would be pretty fun. So if you know anybody can get me a guest spot, that would be awesome.
Next thing you know, he starts a new career as a dub master.
I don't think so. And one person from the very beginning said that they're choosing data access objects, so we're just sending your commiserations to you. Continue for EF Core, and then kind of following up from that, we had somebody saying that EF Core is one of the best ORMs on the market. We like to think it is the best, but that's fine. One of the best is good enough, I suppose.
Thank you.
Okay. Anything else from you guys, Shay, Jeremy?
So what you saw was, by the way, 2 optimizations out of there's others. I just wanted to make clear, but those are the 2 we had time for.
Yeah, actually, you can see the PRs and the issues if you go on the releases page for the preview 3. That links to some of the issues that Shay has fixed. In our bi-weekly updates, I list all the PRs that have been merged for that 2 weeks, so you can dig into it there. Everything's on GitHub, so if you're really interested,
I will also do a blog post probably for preview 5. I'm imagining, which is when most of this will already be inside, where I'll probably do this kind of thing, but in written form and so on.
Awesome. So in 2 weeks' time, we have, as Shay said, pagination or pagination, depending on how you say it. I don't know. So I think that's all from us now. And Toast says bye as well. So thanks everybody, and we will talk to you again next
Get my
time.
hand in the camera. There we go.